This is Jude from Department of Physics, St.Joseph College of Arts and Science, Cuddalore. We can see the basic fundamentals in the crystal lattices. As we going to start, the basic fundamental thing what we have to know is the lattice points. A lattice point is an ordered array of points describing the arrangement of particles to form a crystal. So this is exactly like you can imagine like egg in an eggshell. So similar to that, in a crystal, if these lattice points, the atoms are arranged in a particular way such that it is properly set, we can say it is a crystal, and the point where the atoms are stored are called as lattice points. And the important parameter is defect. And what do you mean by defect? Defect means an imperfection in the regular geometrical arrangements. As you know, as the name insists, it is a defect. If there is any discrepancy in the geometrical arrangement, it means that it is if the atoms are not properly arranged, you can call it as a defect. And these defects are categorized in terms of dimension, 0 dimension, 1 dimension, and 2 dimension. This table clearly classifies the defects in a crystal. The major categories are point defect, line defect, and surface defect. As point defects, it is further categorized as vacancy, interstitial, substitutional, Scotty, and Frankel. And in line defect, there is edge and screw dislocations. And in surface defect, it is categorized as grain and twin boundaries. First one is zero-dimensional defects. So in this zero-dimensional defects, it is interstitial and substitutional. As the name indicates, it is interstitial. The atoms normally in unoccupied site. You can see the image over there. A crystal, it is an atom is placed in an unoccupied site. It means it is not properly arranged. It is fitted into a properly arranged crystal. It is fitted in between that. So if a foreign atom, we can say it is a foreign atom. It is an interstitial defect. Substitutional defect. An atom replaces the original atom in the lattice site. That is the problem. You can see the diagram. The green color points over there indicates the substitutional impurity. It means atoms of another type replaces the exact lattice point, that is which is in the original crystal. It replaces the original atom by a substitutional atom. That is, another atom replaces those sites. And this is vacancy. Vacancy, as the name clearly indicates, there is a defect. It means the atom is not over there in the original site, so it creates a vacancy over there, so it is also a defect. Next one is Scotty defect. In this defect, both cations and anions leave their sites and create a pair of vacancy defects. As you see there in the diagram, the plus and minus, the cations and the anions leaves their original site, their original place. They left their original place. Due to that, there is a vacancy created by both these cations and anions in the crystal structure. And these are categorized as Scotty defect. And another one is important one is Frankel defect. An atom or cation leaves its original place in lattice site and occupying in interstitial position. As you see, it doesn't replaces make a vacancy over the lattice site, but it goes and places in the interstitial position. In between the original atoms, the cation leaves and occupies the interstitial position in the crystal. That is characterized as Frankel defect. And all these are what we have seen before is zero-dimensional. Now we can go through one-dimensional defects. As you already seen that edge and screw dislocations, these are categorized as dislocations. Edge dislocation, this occurs when the extra atoms are inserted into a plane in the crystal lattice. You can see over there in the diagram, 3 atoms in this diagram. It is represented as 3 atoms. There is an extra row which is inserted in between the original atom. So there is a deviation or there is the irregularity happens, the regular pattern gets disturbed due to these extra rows of atoms. 3 atoms are represented over there in the diagram. So due to this there is a deviation in the edge, and you can call it as a edge dislocation. The another one is screw dislocation. Screw dislocation means a dislocation in which the atoms are arranged in a helical pattern. It is normal to the direction of the stress. From the diagram you can see over there is a stress is given which is normal to the crystal structure, and there is, due to the stress which is applied normal to it, there is a dislocation happens. The surface is not in a evenly, it is not properly arranged because of the stress given, and these dislocations happens exactly perpendicular to the surface. It means crystal. So this is categorized as screw dislocation. And in two-dimensional defects, it is a surface defects, and it is mainly classified as grain and twin boundaries. And in grain boundaries, the small misfits or small disarrangements which is related to one another, or a change in the crystal orientation across them. So we can see a group of atoms related to the another set of group of atoms. There is a mismatch, that is, the orientation is different from each set of group of atoms. So they can make a boundary over there, and in those boundaries, in those regions, they have a similar pattern, and with respect to the another group of, it means another set of atoms. So you can clearly see a boundary of atoms which is oriented in a specific direction, and related to that another set of atoms which is not oriented in the relative boundary. So it is a different orientation is set up. So arranging in those boundaries as a defect, we can say it as a grain boundaries. The boundary itself differentiates the set or group of atoms which is oriented differently related to each other. So these boundaries are drawn, and these boundaries are called as grain boundaries. And the last one is twin boundaries. As you see in the image, it is like a mirror image. When the crystals on either side of a plane, so we can consider this as a plane. When you see a plane of atoms in one side which is exactly differentiates from the other plane, when you see from another side, so it reflects the mirror image of that atom, set of atoms. There is group of atoms arranged in a particular way. So it reflects the mirror image of the another side. Since the boundary will be a single plane differentiates these two, and one is the mirror image of the another. The same dislocation or the misorientation happens in one way which reflects the mirror image of the another one, and this is categorized as twin boundaries. And finally, three-dimensional defects, and we can say it as a volume defect. Usually we termed as a void. You know that when there is a multiple number of atoms are missing in their lattice site. As I already said, that the lattice site is a place where the atom is stored. It is similar to the eggshell where the eggs are placed, and you can consider a single egg as an atom. So when multiple number of atoms are missing in the lattice sites, so we can term it as a void. So the next one is cracks. As the name insists, there is a crack arises these small electrostatic dissimilarity between the stacking layers. As you know, the cations and anions, there may be number of cations, there may be number of anions. Due to this electrostatic plus plus or minus minus, due to electrostatic repulsion or attraction, there is a dissimilarity. There may be a small misorientation in the arrangement. So we can, the combination of all these things, we can make a crack. So we can term this as a crack. And final one is inclusion. This happens when foreign particles, as the name means, it is included. Inclusion happens usually precipitate particles. When there is a precipitation happens in that crystal, some of the foreign particles maybe get inserted into and make an interstitial place over there. And this category is volume. There is a change in the volume, so it is considered as a volume defect, and we can name it as an inclusion.